everyone, and welcome back to Wired-Tec. It's great to have you here for another deep dive into the history of computing. If you're enjoying this series, do me a huge favor and hit that subscribe button and give this video a like. It really helps the channel out. All right, let's get into it. Last time, we talked about how the tiny transistor kicked the clunky old vacuum tube to the curb. It was a huge step forward, making computers way smaller and more reliable. But as it turns out, solving one giant problem created a completely new and honestly a pretty mind-bending one. Today, we're going to see how engineers had to shrink the brain of the computer all over again. So, just to recap where we left off, the transistor was a game changer. It was solid, it was small, it didn't overheat, everything was looking up. Computers got faster, they didn't break down nearly as often, but this incredible progress led to a brand new massive headache. Funny how that works, isn't it? I mean, think about it. The switch itself was now microscopic compared to the old vacuum tubes. So what could possibly be the issue? The components were tiny, but the computers themselves weren't really shrinking as much as you think. And that's the real mystery we're gonna crack today.
Yeah, the problem wasn't the parts. It was putting them all together. The best analogy I can think of is this. Imagine you're building a massive, sprawling city, but you have to lay every single wire, every single pipe, and every single road by hand, one at a time. That's pretty much what computer manufacturing looked like.
The engineers themselves had a name for it. They called it the Tyranny of Numbers. See, to build more and more powerful computers, you needed tens of thousands, then hundreds of thousands, and eventually millions of these little transistors. And every single one had to be individually soldered into this just nightmarish tangled web of wires. And this whole hand wiring process, it was a total disaster just waiting to happen. You've got rooms full of people, hunched over, painstakingly connecting thousands upon thousands of tiny wires. If even one of those wires was misplaced, or if you had a cold solder joint, just an imperfect connection, the whole multi-million-dollar machine could be rendered useless. It made computers outrageously expensive and, of course, physically massive. And the real irony? All that wiring, all that physical distance the electricity had to travel actually slowed the signals down, creating a speed bottleneck.
But just when it looked like this sheer complexity was going to grind all progress to a halt, a totally revolutionary idea popped up. What if you didn't have to wire anything by hand? What if you could build the entire city, all the buildings, all the roads, the whole shebang, all at once?
And that idea was the integrated circuit, the IC, or as we all know it, the microchip. A couple of brilliant minds, Jack Kilby over at Texas Instruments and Robert Noyce at Fairchild Semiconductor, they basically figured out, independently by the way, how to manufacture an entire circuit, the transistors, the resistors, and all the connections between them on a single tiny slice of silicon. It was an absolutely monumental breakthrough. The difference was just night and day. We went from having a big box of individual parts that had to be painstakingly wired together to a single all-in-one unit. The manual wiring was gone, replaced by microscopic connections printed right onto the silicon. This made them unbelievably reliable, way smaller, and of course, lightning fast. The tyranny of numbers had been totally overthrown. And this new tech hit the market almost immediately. In 1966, Hewlett-Packard launched the HP 2116A. This was a big deal. It was HP's very first computer, and it was the first major commercial product built from the ground up with integrated circuits. The microchip era was officially here.
As this technology started to mature, a guy named Gordon Moore, one of the founders of Fairchild and later Intel, he noticed this really startling pattern. He saw that engineers were basically doubling the number of components they could cram onto a single microchip roughly every 2 years. This little observation became what we now call Moore's Law. And it was this powerful, self-fulfilling prophecy that promised an exponential explosion in computing power and at the same time, a total collapse in cost.
So, problem solved, right? The hardware was getting cheaper, faster, and way more reliable. But, fixing one problem just revealed another, equally frustrating one. A new kind of chaos started to emerge, but this time, it was all about the software. Okay, this is a really crucial point. Back then, every single computer model was basically a one-off, a custom piece of engineering. So software written for one machine would absolutely not run on another. Not even a different model from the very same company. Now, if you're a business, this is terrifying. It means if you outgrow your computer, you have to throw out not just the hardware, but every single piece of custom software you'd spent years and a fortune developing. It was a huge risk. So the company that could solve this software trap, well, they were poised to dominate the entire industry for decades. And that company was IBM. Their idea was so simple but so revolutionary. Don't sell individual one-off computers, sell a family of them. This quote really gets to the heart of what they were doing with the IBM System/360, which they introduced back in 1964. The promise was simple. You could buy a machine that fit your needs and your budget today, and later, when your business grew, you could upgrade to a bigger, more powerful model, and, this is the magic part, all of your old software would still work perfectly. And the process was so straightforward. A company could start out with a smaller, more affordable machine, say a Model 30. Then, as their business expanded, they could seamlessly upgrade to a much more powerful Model 50 or even a Model 75 and just move their programs right over. This completely changed the economics of computing. It lowered the barrier to entry, and it made buying a computer feel like a safe, long-term investment instead of a massive gamble. So by the late 1960s, all the pieces were finally falling into place. The integrated circuit gave us the raw power, and the IBM System/360 gave us the standardization. The mainframe era had truly begun. Computers were now these reliable, scalable tools, but they were still the exclusive toys of massive corporations, governments, and universities. You have to picture it. These machines were giants. They filled entire air-conditioned rooms, tended to by technicians in white lab coats. The brain of the computer had been shrunk down onto a chip, that's true, but the machines themselves were still totally out of reach for ordinary people. Which brings us to our final cliffhanger question. What would it take to shrink these room-sized brains down to something that could actually fit on a desk? What would it take to finally put the power of computing into the hands of everyone? Well, that's what we'll be talking about next time.